Well, welcome back to Maths with Kirin. We're up to lesson 6. So today we're looking at solving quadratic equations, and I'm also going to go through solving quadratic inequalities. That's come up in previous papers in the past, normally at the level. Quite similar the skills to solving quadratic equations. Okay, so I'll run through it, but just do what you feel is comfortable for you. If you don't think you're all quite ready for solving quadratic inequalities, then skip through that bit, just focus on solving quadratic equations, and then when you're comfortable with that, you can move on to those sort of slightly more challenging inequality questions. So like usual, I'm going to run through a few examples with you, and then I've got some exam questions from the last couple of years that I'll go through as well. So we'll just get started. So quadratic equations, we've talked about these before. They are equations where your highest power of x is a 2. Okay, and we've looked at factorizing quadratics. So again, today we're going to be utilizing that skill when we are trying to solve the equations. Okay, so if we have a quadratic equation, to solve it, we want to make the equation equal to 0. Now that's quite different to linear equations when we try and isolate our x or our variable. For a quadratic equation, we want everything on one side of the equation. So we make it equal to 0. And the reason we do that is because we want to factorize the expression. Okay, so when we factorize it, we've got two things that are multiplying. And if you have two things that are multiplying together to give you 0, then you know that one of those two factors has to be 0. Okay, it's the only way that you can multiply two things and get 0 as your result, is if you have one of them actually being 0. So when we factorize our expression, the next step is to make each factor equal to 0, and we solve for that variable. So often with a quadratic equation, you'll end up with two solutions. Sometimes there might only be one. We call that one repeated solution, but in most cases you'll end up with two solutions. If you have a contextual question, then you'll need to just refer back to the question and make sure both of the solutions you have make sense. Sometimes you might have a scenario where, for example, a negative number doesn't make any sense. So while mathematically it's a solution, given the context, we would discount that particular solution. So just be careful with that. So these first questions are all just straightforward examples. We have no context. We're just practicing that skill. But that context will come in when we look at the old exam questions that we're going to go through towards the end of our session today. So this first example, we've got 3x squared plus 11x plus 6, and it should say equals 0. I missed that off my notes, so we'll just get that here. So we actually have an equation to solve now. So the first thing we want to do is make sure it's equal to 0. Well, that's already done. So we move on to the next step, which is to factorize. So using the factorizing skills that we have covered a couple of times now, they've been used not just for obviously factorizing quadratics, but we use them for simplifying some of those fractions as well. So if we factorize this, we know that we're going to need a 3x and an x. Our equation will still be equal to 0, so I throw that in first just so I don't forget it. We want two numbers that multiply to give us 6, remembering that one of them, when we expand it out, is going to be multiplied by this 3 here. So if we just think factors of 6, either 6 and 1 or 2 and 3, I'm going to start by trying 2 and 3. So if we expand this out, 3x times 3 would give us 9x, and another 2x would give us the 11x that we are looking for. And they're both positive because we have a positive 11x and a positive 6. So we're factorized. So now we need to make each factor equal to 0. So if we start with the left-hand side, we either have 3x plus 2 is equal to 0, or x plus 3 is equal to 0. Okay, because these two things are multiplying to give us 0, the only way that can happen is if this ends up being 0, which means 0 times any number will give us 0, or this is 0, in which case 0 times whatever the happens to be will also give us 0. So that's why we end up with these two expressions here. So solving this, we've now got a linear equation. We know how to do those, solve those from our last lesson. So 3x would be negative 2. So x would be negative 2 over 3. Or in this case, x would be negative 3. So there are our two solutions. X is negative 2/3 or x is negative 3. Okay. Question 2, same thing. So going through that process, at the moment we've got our equation equal to 5. We need it to be equal to 0 in order to factorise. So if we bring that across first by subtracting 5, and now we factorise. So if we've got 4x squared, we can either have a 4x in the first bracket and an x in the second, or we can have a 2x and 2x. The 5 here, that's a prime number, so we know it has to be 5 and 1. We can't play around with that. So I'm going to start by just trying 2x and 2x equals 0. So we know it's a 5 and a 1, and we're trying to get to 8. So it doesn't actually matter which way around I do the 5 and the 1, because I've got a 2x and a 2x. So both of the numbers will be doubled. So if I put a 5 here and a 1 here, we want to get negative 5. So we know that one of them has to be negative. Multiplying 5 by 2x gives us 10x. Multiplying 1 by 2x gives us 2x. And we want a difference, because we've got a negative 5 here, a difference of 8. So we've got the right numbers. We now just need to get the right signs. If we want positive 8, then we need positive 10 minus 2. So positive 5 minus 1, making each factor equal to 0. So 2x plus 5 is equal to 0, or 2x minus 1 is equal to 0. So 2x is equal to negative 5, x is equal to negative 5 over 2, or 2x is equal to positive 1, which means x is equal to positive half. So two solutions, x is negative 5 over 2, or x is positive half. And one more example for this. A little bit more going on. We've already got something factorised, but because we have this positive 9x, we're going to need to expand first, collect all of our like terms, and then see if we can refactorise. So we're already equal to 0, so we don't need to worry about that. So expand out, simplify, see if we can refactorise. So when we expand, we get 5x squared. 5x times negative 6 is negative 30x minus 2x plus 12, because it's negative 2 times negative 6, plus 9x is equal to 0. 5x squared has no like term, so that stays as it is. Negative 30x minus 2x is negative 32x, plus 9x is negative 23x, plus 12 equals 0. Okay, so now we have our quadratic. We want to factorise. So 5x squared means we have a 5x and x. We've got 12, so we can either 12 and 1, 4 and 3, 6 and 2. So I'm just going to start with 4 and 3. So 5 times 3 would give us 15, and 4 would only give us 19. We need 23, so let's try them the other way around. If we put a 4 here, 5 times 4 is 20, and then 3 would give us our negative 23. Oops, sorry, it should be 3. I was thinking about 23. And we know that both of these numbers need to be negative, because they're multiplying to give positive 12 and they're adding to give negative 23. So expanding that out, 5x squared minus 20x minus 3x plus 12. This will be good. So then our two solutions, either 5x minus 3 is 0, or x minus 4 is 0. 5x is 3, which means x will be 3 over 5, or x is equal to 4. Okay, so again, two solutions, 3 over 5 or 4. Okay, so that's solving quadratic equations. Make it equal to 0, factorise, make each factor equal to 0, and solve for your two solutions. Sometimes you might need to do some expanding and simplifying in that process, but that's how that works. Okay, and remember, the reason we're making it equal to 0 and factorising is because we're finding two things that multiply to give us 0. And so if that happens, then one of those two factors has to be 0. Cool. So I'm going to talk through solving quadratic inequalities. So as I said before, this has come up at excellent level. If you are not quite so comfortable with solving quadratic equations, then by all means, listen. But you might want to practice solving quadratic equations and make sure you're really comfortable with those before you move to inequalities, even though a lot of us is the same. So quadratic inequalities are solved initially by finding what we call the critical values, and that's the x values that would make our inequality equal to 0. Okay, and that's the same score that we just went through. Okay, so they're those critical values. Once we've got those, we can use substitution to find the range of values that we require. And I'm also going to show you kind of graphically how that works. Okay, so sometimes if you can sort of see what's happening, it might help you to make a little bit more sense of what's going on. We do need to remember if we're going to multiply or divide the whole inequality through by a negative number, we still need to reverse the inequality just like we did with those linear equations in that last lesson. Okay, so we're going to start with this first one. So we want to factorize. I'm going to actually take out our common factor first because you can see that 2x squared and 8 have a common factor of 2. So if we take that out in front, we've got x squared minus 4. That's still less than 0 at the moment. This we can factorize. It's that difference of 2 squares. We've seen those quite a few times. So 2 stays out in front and we have a plus 2 and an x minus 2 as our two factors. So our critical values happen when this expression we've already factorized is equal to 0. So that would mean that x is negative 2 or x is positive 2, okay, either of those. So if we just take a side note for a moment and I just sort of show you what's happening. This is obviously a quadratic equation, the highest power of 2. When you graph that, it creates a parabola. Okay, so you should have seen parabolas, even if you haven't done stuff for tables, equations, and graphs, yet you should have seen parabolas last year, so they shouldn't be completely unfamiliar to you. These x values here, when we make our equation for a parabola equal to 0 and we solve for x, we're finding the x intercepts. So these two values are telling me that our parabola is going to cut the x-axis at negative 2 and positive 2. Okay, and when we have this expanded out up here, we have a positive x squared. So we know that our parabola is going to be up like a cut. So it's going to come down, this is a rough sketch, like this. Okay, that keeps going. We are trying to find where the equation, or where the parabola in this case, is less than 0. So that means we're looking for the y values that are less than 0. So this is our y-axis. All of these values here are positive y values. All of these values down here are our negative y values. Because we want less than 0, we're interested in this area of the graph. Okay, so we get negative y values, or values less than 0, when x is between negative 2 and positive 2. These two values here, negative 2 and positive 2. So our solution for this, that's less than 0 when negative 2 is less than x, or in other words, x is bigger than negative 2, but at the same time, x has to be smaller than positive 2. So this is how we can write our inequality. X goes in the middle. We're saying that x is bigger than negative 2 and x is smaller than positive 2. So that's this range of values here. Now again, this is just a straightforward skill. If you have a context, it might be that negative numbers don't make sense, or you have to have whole numbers for some particular reason. So you might not need to write your answer using the inequalities like this, based on your context. So again, just keep that in mind. Okay, but that's how the quadratic inequalities work. Okay, so finding those critical values, same process as solving a quadratic equation, and then we just need to figure out what area of the graph we're interested in. As I said up here, you could use substitution. So when you know your critical values are negative 2 and 2, you can use any x value between these two. So for example, you might use 0. It's nice and easy. You substitute it into here. You get 0 plus 2, which is 2, and 0 minus 2, which is negative 2. 2 times positive 2 is positive 4, times negative 2 is negative 8, which is obviously less than 0. So we would know from that substitution that anything between negative 2 and positive 2 would give us negative values. So that would also indicate that we want this as our solution. Okay, so graphically, if you want to draw a quick sketch so you can see what's going on, by all means do that. Or if you're happy to use substitution, that also works. So I'll go through another example with you. So we've got 3x squared plus 13x plus 4 is greater than 0 this time. So to find our critical values, we want to make it equal to 0. Okay, so our critical values happen when 3x squared plus 13x plus 4 is equal to 0. So factorising, again, that 3x squared means that we have a 3x and an x, and we make it equal to 0, so we don't forget that bit. We can either have a 4 and a 1 or a 2 and a 2. We need to get to 13, so I'm going to try 4 and 1 first, because I know that 4 times 3 is 12, plus 1 is 13. Okay, and they're both positive, because we have positive 13x, positive 4. So our critical values happen when 3x plus 1 is equal to 0, 3x is negative 1, which means x is negative 1 over 3, or x is equal to negative 4. Okay, so we have our two critical values. So again, if we have our little parabola sketch, we've got a negative 4 and a negative 1/3. Oops, that's a really terrible 3. Positive 3x squared means that we have our parabola going this direction. Okay, quick sketch, doesn't matter how far down you write that, it's just to see what's kind of going on. And this time we want bigger than 0. So we want this and this. They're obviously disjointed. So we're going to write two statements. This happens when x is bigger, or sorry, x is less than negative 4. So all of these x values to the left here. This part of the graph happens when x is bigger than negative 1/3. So all of those values to the right. So solution. So 3x squared plus 13x plus 4 is bigger than 0 when x is less than negative 4 or x is greater than negative 1/3. Okay. Again, we could use our substitution. So if we picked a value in between negative 4 and negative 1/3 and substituted it into this up here, we would find out whether it's negative or positive. Okay, and we could use that. Otherwise, I actually find quite helpful. Cool. Third one. So this looks third and final example, and then we are going to go on to some exam questions. So this one, 13x plus 10 is greater than 3x squared. So we need to bring our 3x squared to the left. So we're going to subtract 3x squared plus 13x plus 10 is bigger than 0. To find our critical values, we need to make it equal to 0. We get negative 3x squared plus 13x plus 10 is equal to 0. Finding those x-intercepts. It's harder to factorise if you have a negative 3x squared. Some people find that quite tricky. So what we can do is multiply everything by negative 1. So we get positive 3x squared minus 13x minus 10 is equal to 0. Now when we do that, we've now changed this equation. So we've got 3x squared minus 13x minus 10 is less than 0. Okay, because we've multiplied everything through by negative 1, our inequality still needs to reverse, just like it did in those linear equations. So this is now what we're solving, because we've multiplied through by negative 1. So from here, we want to factorise again with a 3x squared. So we know we have 3x and x. Finding our critical values means we make it equal to 0. For 10, we can have 5 and 2, 10 and 1. If we try 5 and 2, we want a difference of 13. 5 times 3 is 15. And 2, we take that away, we give us that 13 that we're after. Because we want negative 13x, we actually want to have negative 15 plus 2 to give us our negative 13. And positive 2 times a negative 5 gives us that negative 10. So we know our critical values happen when 3x plus 2 is equal to 0, which means 3x is negative 2, which means x is negative 2 over 3, or when x is positive 5. Okay, if you want to draw your sketch, you can. We've got negative 2/3 over here and positive 5, and we've got this equation because we multiply through by negative 1, so we've got it going like this. Oops. Oh, We want less than 0, so we're interested in these values, and below the x-axis down here. So we have that x value needs to be bigger than negative 2/3, but smaller than 5. So 3x squared minus 13x minus 10 is less than 0 when negative 2/3 is smaller than x is smaller than 5. Okay, again, if you wanted, you could use substitution instead. I would use 0 in between negative 2/3 and 5, and it's really easy to substitute. You just end up with negative 10, which is obviously 0. So we want the area between. Cool. So we're going to have a look at some old exam questions. We've got 5, I think, to go through from 2019 and the 2018 paper. As usual, I've just taken the questions from paper A. So if you want some practice of these things, then have a look at paper B from those years and practice particular types of questions. So this one is just a straightforward solve the equation. Doesn't tell you how to do it. Tell you it's a quadratic. We need to spot that by recognizing that x squared is our highest power, already equal to 0. So the first step that we need to do for this question is factorize. So this one is a little bit tricky in that you've got a 10x squared and you've also got a negative 9. So neither of those are prime numbers. So what you might want to do is just, I guess, think about all of your possibilities and just go through them until you get one that works. So for a 10x, the 10x squared, sorry, you might have a 10x and an x. And for 9, we could have 3 and a 3. Okay, or if we keep with our 10x and our x, we could have 9, 1, or we could have that same thing, but our 1 and our 9 the other way around. Okay, so if we look at these, we need to get negative 9. So we know that one of the numbers has to be negative, which means we're looking for a difference of 27. So 10x times 3 would give us 30. And then if we take 3x away, we get 27. So we've got a difference of 27. We just need to play around with the negative and positive. So this one actually works. If you wanted to check the others, 10x and 1 would give you 10x and 9x. That's not a difference of 27. 90x and 1x is also not a difference of 27. You could keep going through. You might have started with your 5x and your 2x, and you would obviously have 3 and 3, or you could have 5x, 9, and 2x and 1, or 5x and 1, and 2x and 9. Okay, those are all of your possible solutions. If you tried these, you'd also find that you don't get your negative 27. So we know that this is the one that works. We need negative 27, so we're going to have negative 30 plus 3. So 10x plus 3, x minus 3, because that would give us negative 30x plus 3x. Okay, so now we've finally factorized. We can find our two factors. So either 10x plus 3 is equal to 0, so 10x is negative 3, x is negative 3 over 10, can't simplify that fraction anymore, or x is equal to positive 3. Okay. Once you've done lots of these, you might get quite quick. You don't have to write out all of this. You can just go straight to these two solutions, but you do need to show that you've factorized it and try and remember to have that equal to 0 there. That's why, as I said before, I tend to write that equal to 0 first before I even start playing around with numbers. So we've solved that question. In the marking schedule, to get achieved, you set up any one pair of factorized brackets. So any one pair of these, regardless of what signs you have, will give you achieved. Or you could try using that factorizing method that I talked about in the factorizing video, where you multiply your 10 and your 9 to get negative 90. You want two numbers that multiply to give you negative 90 and add to give you negative 27, which would be your negative 30 and 3. So you would then write and factorize down here. 10x squared, minus 30x plus 3x minus 9 equals 0. And then you'll remember we took highest common factor from our first two terms here, which would be 10x, x minus 3. And then from our second pair of terms, we have a common factor of 3, x minus 3 equals 0, because these two brackets are exactly the same. We have 10x plus 3 is one factor and x minus 3 is the other. So if you wanted to factorize it using that method, if you get this far, so you have your 10x cubed minus 30x plus 3x minus 9, or you have these written the other way around, then that is also achieved. Or you don't quite get the factorizing right, something goes wrong with your factorizing, so maybe you have 10x plus 3 and x plus 3 for some reason, you made an error there, but then you consistently solve your quadratic equation, that would also get you achieved. For merit, you need to correctly factorize your expression, and it actually says for merit, correct factorizing regardless of solution stated afterwards. So if you can get your correct factorizing, then you can merit that question, even if something goes wrong when you are solving. That's not always the case. So quite often you will need to get your solutions correct merit. I'm picking that in this particular paper because this was quite a hard factorizing question. They were willing to give you that merit grade if you manage to actually factorize it correctly, even if the solving is not. Cool. Next question, also from 2019. Quite often when solving quadratic equations, you'll get a question around area. Sometimes they give you a formula to work out the area of a particular shape. However, just be warned, you are expected to know that the area of a triangle is half base times height, so don't expect to always get that if you are given a triangle. There is a question that we'll do later on where you're not told that, so just beware, you might not be told that. In 2019, you would have. So the question is asking us, find the value of y so that the area of the right-angled triangle is the same value as the area of the rectangle shown below. All lengths are in centimetres. Note the area of a triangle is half base times height. So we want the area of these two things to be the same. Okay, so to find the area of a rectangle, we multiply base times height or base times width, however you do that. So we have 2y times 3y minus 1. That needs to be the same as the area of the triangle. So the area of the triangle is half times base, 2y minus 2, times height, which is 5y plus 9. So we can expand this out, but we've also got this half out here. So there's, I guess, two ways of dealing with this. We could either bring the half is the same as dividing by 2. Okay, so we could remove this half by multiplying both sides by 2. Or we can actually bring the half into one of these brackets here, not both, any one of them. You want to pick a bracket that's got even numbers because then it's easy. You just end up with whole numbers when you halve them. So for example, if we put the half into this, we'd get 2.5y plus 4.5, and it's going to make things a little bit more difficult when we are trying to factorize. But we can bring a half into here because that would just give us y minus 1. Okay, so that's what I'm going to do. We can expand this out. We get 6y squared minus 2y is equal to, bringing a half in here, we get y minus 1 and 5y plus 9. So now we expand this, our left-hand side stays the same. We get 5y squared plus 9y minus 5y minus 9. So if we tidy this up first, we get 5y squared, 9y minus 5y is positive 4y minus 9. It's a quadratic, we know that because we have our y squared term, so we want to make it equal to 0. So if we move everything to the left-hand side, we can do that. So 6y squared minus 5y squared conveniently just gives us y squared. Negative 2y minus 4y gives us negative 6y. Sorry. And then positive 9 is equal to 0. Okay. So now we factorize a little bit easier because we don't actually have a coefficient of our y squared. So two numbers that multiply to give us positive 9 and add to give negative 6 would be minus 3 times minus 3. And so in this case, we only have one solution. Y equals positive 3, because we will get the same solution no matter what. So for this question, and this is an excellent question, so I might start with excellence and kind of and then go through the lower grade. So for excellence, you get the correct value of y. So you set up your equation, you expand, you make it equal to 0, you correctly factorize, and you get your solution of y equals 3. Okay. For merit, you get a consistent solution from your quadratic equation. So something has gone wrong here. Maybe you made that a negative 9, for example. Instead of adding it when you bring it across, you made it a negative 9. You still correctly factorize for your equation, and you get the right solution for your equation, but the error that you have done somewhere up here means that it's not y equals 3. So that's what you need to do for merit. For achieved, you need to do one of the following. You can either form the equation for both areas. So you write this and this, okay, with your equal sign. You form your equation for both areas. Or you expand the equation for the area of the triangle and you simplify that, which pretty much means you get down to 5y squared plus 4y minus 9. Or you expand both quadratic equations, so you expand the rectangle and you expand this one, except you might still have your half out in front. So you might expand this for your law crab or whatever you use, but you still have that half out in front. That will give you achieved as well. If you consistently simplify your equation to a quadratic, so something goes wrong when you're doing your expanding, but you can consistently simplify that down to a quadratic. So this here, except you have different numbers. Right, that gives you achieved. Or you consistently factorize your quadratic. Okay, so again, you don't end up with this, but you have a quadratic and you manage to consistently factorize that. Okay, so one of those things. Quite a few options for achieved. Merit is getting all the way through, except you've got one sort of error, perhaps in your rearranging. You don't end up with y equals 3 and excellence all the way through. Going on to 2018, so just a straightforward solve, or equal to 0, so we just need to factorize. We know that we have a 3x and an x. This isn't quite as difficult as the one they had in the 2019 paper because 3 is a prime number, so we know that that's the only way that we can get 3x squared. So 8, we can have 4 and 2, or we can have 8 and 1. We want to get a 2x, so we know that one of them is going to be multiplied by 3. So if we had a 4 and a 2, for example, we want a difference of 2. In this case, because we've got negative 8. So 3 times 2 would give me 6, and 4 is a difference of 2. We want positive 2, so if we have positive 6x minus 4x, we get positive 2x, and then negative 4 times positive 2 is 8. So either 3x minus 4 is equal to 0, so 3x is 4, which means x is 4/3, or 1 1/3, or x is negative 2. Okay, so this is a merit question. So if you get your two solutions, 4/3 and negative 2, you get merit. For achieved, you either correctly factorize, so you get this far, or you don't factorize correctly, but you get two solutions that are consistent with your factorized expression. So solving quadratics quite often, you can get merit from. So another question to do with area. We've got a right angled triangle. We're told the area is 35 centimeters squared. We want to find the value of x. Remember, you must use algebra and justify your answer. Throughout your algebra paper, you need to show the use of algebra. So that means that you need to write equations and you need to show that you're solving those. If you just guess and check a value for x, then you won't get full marks. So it's important. Just remember that. Sometimes they might be hint to remind you of that. So area of a right angled triangle. So the area of a triangle is half times base times height. So we want half times 4x plus 6 times x is equal to 35. So most of you will probably write it like this. X plus 6 is equal to 35. Okay. So bringing your half in, we get 2x plus 3 equal to 35. Expanding, we get 2x squared plus 3x is equal to 35. Making it equal to 0, we get 2x squared plus 3x minus 35 is equal to 0. Don't have a common factor of 2, so we know we have a 2x and an x, and it's equal to 0, so bring that down. Negative 35, so it could be 7 and 5, it could be 35 and 1. We want a difference of 3, so I'm going to try 7 and 5. So if we go 5 here, we get 10, and 7 is a difference of 3. So 5, what did I say, and 7. And we want positive 3, so we want 10x minus 7x. We've got ourselves positive 3x. So 2x minus 7 is equal to 0, which means 2x is 7, which means x is 7 over 2, or x is negative 5. When you have your two solutions, go back and check. The area of a right angled triangle is 35 centimeters. What is the value of x? So x is 7 over 2 or negative 5. If this is negative 5, that doesn't make any sense. You can't have a length of a triangle that's negative 5. So while negative 5 is a mathematical solution, it doesn't make any sense for this particular context. So x has to be equal to 7 over 2 as x cannot be negative. So for this question, it is important that you recognize that x being negative 5 is a mathematical solution. So you want to write that down. But then you go that step further and say, well, actually, while it works mathematically, it's not going to make any sense for this particular context. So x has to be 7 over 2. So to get full marks, you need to do that. So for this question, for achieved, you can expand your equation correctly, or you remove your factor of 2 in the bracket, so you get 2x plus 3, or you could, instead of bringing your half into the brackets, you could multiply by half, so you get x times 4x plus 6 equals 70. If you do any of those things, that's achieved. Or if you consistently factorize your quadratic into two brackets, then you can get achieved, but something might have gone wrong when you've expanded. Okay, or you consistently solve, so you might get this right, but you don't factorize it correctly, and then you solve it consistently, and that's also achieved. For merit, you need to do two of those things. Okay, so correctly expand and factorize. Okay, for excellence, you get all the way through and you correctly justify your solution. So you show your two mathematical solutions, and then you justify why it has to be 7 over 2. Okay. So there's one more question. This question, I'm just going to warn you, has a lot of words. It's quite a wordy question. It's from 2018. Don't be afraid to read through things twice, underline things if you need to, in order to help you kind of make sense of what's going on. I'll read through it with you, and then we will see if we can make sense of what's going on. So Sophia and Tama's grandmother is a maths teacher. She bought both of them some fidget spinners, but they have to solve a maths problem before she will give this fidget spinner to them. Tama thinks that because he is older, he should get more fidget spinners than Sophia. They are told that the number of fidget spinners they will each get relates to the number n. That's our variable. Their grandmother says the number of fidget spinners that Sophia will get is this number n cubed plus 3 times this number, which can be written as n cubed plus 3n, or that's the same as n times n squared plus 3. Okay, taking out that factor of n. Tama will get the number n squared times 2 plus 6 times the number n. The question is asking what value or values could n have so that Tama gets more fidget spinners than Sophia. Show your use of algebra in solving the problem and justifying your answer. Okay, so there's a lot of information up here. That's all the contextual information. The stuff that we really need to work with is in these two paragraphs here. So we know that Sophia, and we can write this down on our piece of paper, is getting n cubed plus 3n, which we're told is the same as n times n squared plus 3. Tama, they haven't given us the equation, but they've told us, so we need to put the words into a mathematical equation. So Tama will get the number n squared times 2 plus 6 times the number n. He's going to get 2n squared plus 6n. The number n squared times 2 plus 6 times the number n. Okay, so we've got two expressions, one for Sophia, one for Tama. The question is asking what values or value could n have so that Tama gets more fidget spinners than Sophia. So Tama needs to get more fidget spinners than Sophia. So that means we've got 2n squared plus 6n has to be greater than n cubed plus 3n. Okay, so you'll see that all of these have a common factor of n. So if we take that out on both sides, we get 2n plus 6 has to be greater than, and this we already know because we were given that before, n squared plus 3. Okay, so because these both have a factor of n, we could actually divide both expressions through by n, which means that these will cancel out. So we now have 2n plus 6 has to be bigger than n squared plus 3. Looks much more friendly now that we don't have any cubes going on. And we've got a quadratic because we've got our highest power n squared. So to solve our quadratic, it's a quadratic inequality, we need to move everything to the left-hand side to get it equal to 0 so we can find those critical values. So moving everything across, we have negative n squared plus 2n plus 6 minus 3 gives us plus 3 has to be greater than 0. Again, this negative n squared, you might find it a little bit hard to factorize. So if we multiply everything through by negative 1, we get n squared minus 2n minus 3 is less than 0. Don't forget to switch your inequality because we're multiplying by a negative number. So now we can find our critical values. N squared minus 2n minus 3 is equal to 0. So, factorizing. 3 means that we have to have a 3 and a 1. N squared means that we just have an n and an n. We want negative 2n, so negative 3 plus 1. So n is 3 or negative 1. So if we wanted to think graphically again, we have negative 1 and 3. It's a positive n squared, so we know it's like this. We want less than 0, so we're interested in these values here. So technically, n squared minus 2n minus 3 is less than 0 when negative 1 is less than x, or x is bigger than negative 1, but x is smaller than 3. And I've written x, sorry, I should n. Okay, so if we go back to the context, what is this n? They are told that the number of fidget spinners they each will get relates to the number n. So we can't have a negative n. That doesn't make sense in this context. And we also can't have fractions, okay, or decimals, because we're talking about the number of fidget spinners. So we also can't have 0. We can't have no fidget spinners. They're going to get some. So of these values, actually, for this particular context, n can't be negative 1, negative, can't be 0. So it could be 1, could be 2, can't be 3, it has to be less than 3. So our only solutions are n equals 1 or 2. That's it, based on this particular context. So this is an excellent question. and there's obviously quite a lot of work gone into this, solving this particular problem. So if we start with excellence, to get excellence, you find your solution and you justify your interval. If you left your answer as this, so you didn't link back to the context, so you said that n had to be bigger than -1 but less than -3, you still get excellence for this question. Okay, they won't penalise you for that. This is obviously what we're really after, but if you leave your answer as -1 is less than n, which is 3, you still get full marks. Okay, so you still get excellence for either of these two solutions. Okay, and we should say as n cannot be negative or 0. Sorry, I did say that, but we probably should write that down. So justifying why we've said it's only 1 or 2. Okay. For merit, you generate a simplified quadratic, but you ignore the inequation. Okay, so you simplify your quadratic, but you've left these all as equals. Okay, so you end up with an equal 0. Okay, that's merit. Or you correctly solve a consistent quadratic to give two solutions. So you solve, you sort of get this far. You give your two solutions, but it says correctly solve a consistent quadratic. So something might have gone wrong, but you end up factorizing, which is consistent with whatever quadratic expression you end up with. And then you solve that consistently, that gives you merit with your two solutions. For achieved, you correctly write the equation or the inequation for both Sophia and Tama. Okay, so you get this far. We can have a greater than sign. If you write them the other way around, you might have a less than sign. You might have a greater than or equals to sign, or you might even just have an equal sign in there. Any of those things will be fine to get you achieved. Or you equate your expression consistently to a quadratic. So something goes wrong down here when you're expanding, but you consistently manage to get down to a quadratic, even though you don't factorize that. That will give you achieved. Or you have a consistent relationship involving n. Okay, so maybe you don't get your equation right up here, but you consistently work that through to get the relationship involving. Cool. That was a particularly tough excellence question. Solving quadratic inequality is pretty hard, and then on top of that, there was a lot of material to read through in order to just get your head around what was going on. If you are going, to have a question like this in your exam and you're not really sure where to start, what words, don't spend a huge amount of time trying to work through it. If you've got other questions that you could be doing instead, you can always come back to it at the end. But if you spend, sort of 20 minutes trying to get your head around this problem, then you might miss out on doing some questions later on in the paper that you're more confident and comfortable with. So if you've had a read through this and you just haven't quite got your head around it, not quite sure where to start, then move on and come back to it at the end. Because you hate to spend a huge amount of time on a question like this and miss out on marks that you could get much more comfortably in the paper. That's my word of wisdom, advice. Cool. Well, that's the last question to go through today. So that brings us to the end of lesson 6, solving quadratic equations and inequalities. So just throwing my timetable up, on Wednesday I'll be back and we are solving simple equations involving exponents. So those exponential equations will come in on Wednesday. So that's what we'll be looking at doing. If you're working through the stuff, you get stuck, of course, you'll probably be able to ask your own math teacher. But if you wanted, you can always email me and I'm happy to go through any questions that you're stuck on during my Thursday sessions, 5:30 on Thursday. So just email me or you can message me through the Facebook page in order to do that. That would be awesome. Happy to help. Otherwise, hope to see some people around on Wednesday looking at those equations. So, if you like this, please share with friends. like it or subscribe to the YouTube channel. That would be really awesome. Thanks for your time, and I hope it's helpful.